In this video, we're going to learn how to identify where an image in a plane mirror would be found and how we can locate it. So first, let's review how light travels. So remember, light travels in straight lines as long as it's traveling through the same medium. So if it's traveling through air or if it's traveling through water. So the medium is the thing that the light is traveling through. So when light hits another medium, it will do one of two things. It will either reflect, so bounce off of the surface of that second medium, or it'll start traveling through the medium, but it bends or refracts. So the two examples are shown here. So the flashlight shining on this mirror, and it's all reflecting back to the person's eye. In this second example, we have a straw and a glass of water. You've probably noticed this before. So the light gets bent. So it actually looks like the straw itself is bent, but it's actually the light that's bending to give us that image. So that's refraction. This is reflection. So we're going to look at a few different terms and then take a look at what they look like on an image. So there's the incident ray. So that's the light ray that travels from the source to the surface. So I'm just going to go to our image. So this is our surface, our mirror in our example. So the incident ray, so imagine there's a flashlight or something here. So the light is shining to the mirror. That's the incident ray. The normal is a line that's perpendicular to the surface. That's an imaginary line we're going to draw, like this one's drawn here. So this is perpendicular. Remember, perpendicular is a 90-degree angle from the mirror. And then the next term is the reflected ray. So reflected ray is this one here. So it's the ray that after it's hit the mirror, it bounces off. So it's the light ray that returns from the surface and it meets where the incident ray meets the normal. So the incident ray goes here, hits there, we draw the normal, a 90-degree angle, and this one bounces off. And if you notice, it bounces off in the same angle from the other one. So the angle of incidence is the angle between the incident ray and the normal, and the angle of reflection is the angle between the reflected ray and the normal. So this is the angle of incident, and this is the angle of reflection, and this says that they're equal. So if this was 45 degrees, this would be 45 degrees. So the incident ray, the reflected ray, and the normal are all on the same plane, so they're all happening in the same plane. And in a plane mirror, or another word for plane mirror, is just a normal flat mirror that you would see if you were looking at yourself in the mirror without a distorted image. So we'll talk about the other mirrors later, concave and convex. So in a plane mirror, the angle of incidence is the same as the angle of reflection. And we compare it with this normal. Once we've found our image, we have to describe it using 4 characteristics. We call them the lost characteristics: L for location, O for orientation, S for size, and T for type. So this is our image. So we'll say location. Is it in front of or behind the mirror? Is it closer or further away from the mirror? So that's the location. The orientation, is it upright or inverted? The size, is it the same size or is it bigger or smaller? And then what type of image? Is it virtual or real? And we'll take a look at what that means a little bit later. So we're going to learn about mirrors and the laws of reflection. So to be able to figure out where your image is going to appear, the first thing that you're going to do is you're going to draw some lines from some of the points on your object. So this pencil has a top and a bottom. So we're going to end up doing 2 lines to help us figure out where the pencil is. So first thing you're going to do for point A is you're going to draw a horizontal line. We'll practice this on the next slide. Horizontal line from the top of the object to the mirror, and then you draw the reflected ray. So remember, it bounces back at the same angle, so straight back. So it's going to go to the mirror and straight back. Then we're going to draw another line on an angle, and it doesn't matter the angle you just pick, then you'll draw a little normal, and then you're going to draw a reflected ray that goes the opposite direction, but at the same angle from the normal. So if this was 40, if this came into the normal at a 45-degree angle, you're going to draw a 45-degree reflected ray. And then once you've drawn that, you're going to extend both the reflected rays until they meet. So we would extend this horizontal line over, and then the one that bounced off, so we extend that. Wherever that meets, that's where your point A is on the other side of the mirror or behind the mirror. And then you'll do the same thing for point B. So now we're going to find our image using those rules. So the first step is to draw a horizontal line from the top of your object to the mirror. So we're going to do that right now. Oops, that's not so straight. So there's my straight line, and then I'm going to reflect it back at the opposite same angle from the normal. And right now, while I'm at it, I'm going to draw out the dotted line behind, like so. So now we'll draw our angled line going to the mirror. It doesn't matter the angle you draw it at, as long as it's a straight line going from the top of the image. So I'm going to draw that line there. Now I'm going to bring in my protractor. So when we look here, I accidentally drew the line a little longer, so it's actually going into the mirror. So I've lined the protractor from the 0 line. That's the part that's along the mirror. And then our normal would be the 90-degree line that's coming out here. So we need to measure the angle from the normal to where my line is traveling. So that is 10, 20, 31 degrees. So that means that my reflected ray also needs to be 31 degrees from the normal. So 10, 20, 31. So right here should be my line. And now I'll extend that line back to the mirror, like so. It's not the perfect. I'm going to undo that and try again, like so. And then I need to extend the light rays back till it hits and meets. So that's where my first image is. So now we're going to do the same thing with point B. So the first thing we need to do is draw our straight line. I'm just going to use the protractor for this just because it has a horizontal line that I can use. So there we are. I'm going to pick my new pen. So I'm going to draw a straight line in, like so. Didn't do a very straight line. My straight line in. And then I'm going to reflect it back. I'm going to extend the rays like that. This next thing I need to do is draw an angled line. So I can draw that any way I want. I'm going to actually draw it downwards from the eraser to the mirror, like so. And now I need to align my protractor. So we're going to put the protractor right here. And if I look, I actually did exactly 20 degrees for my incident ray. So now my reflected ray will also be 20 degrees. I'm going to draw it right there. So from the 70 to the 70. So I'm going to draw that line in, and then I'm going to extend like so. So my other point will be there. So there's my pencil, like so. And now we can analyze our image on our next slide. So you can see that it's kind of pretty much the same distance. It is the same distance. It's upright. There's lots of characteristics that are the same. There are some differences. So we're going to take a look at our lost characteristics now. Here's the worked example that's from the resource that I got the pencil image from, but you can see here it's very similar to our own. Mine wasn't perfect because of my limitations for my my ruler and my protractor, but let's talk about the location. So the location is the same distance from the image, but behind the mirror. It's not really behind the mirror, but you know what I'm trying to say. The orientation is upright, but it's left, right, reversed. That's why when you look in a mirror, if you have some writing on your shirt, it'll be backwards because it's still upright, but it's reversed left to right. The size is the same size. The pencil didn't change. And the type of image is, it's virtual. So anytime your image, if it's drawn behind your mirror, it's a virtual image because it's not really behind the mirror. It's just where it appears. So that's our image characteristics.